Hey everyone, Kevin from MechanicalAdvantage.com. In today's video, I want to draw up a small steel part. After I get it drawn, I'm going to add the toolpath for the top side and the back side. And then in a future video, we're going to go to the Silex7 in the garage and machine this part. The part that I want to make is a T-slot nut. And if you're not familiar with them, T-slot nuts slide into the T-slots of a machine table, and then you can bolt things down like vices or other accessories like strap clamps. Right now, many of you are probably wondering why I am making my own T-slot nuts when you can readily go online and buy them. And the reason for that is on my generation of Silex7, the T-slot on the table is a little narrower than what a standard T-slot nut would be. So originally I bought a set of Tico T-slot nuts, and then I took them to a machine shop and had them ground down to size because those T-slot nuts were hardened. For this, I'm just going to use some 1018 steel that a customer of mine cut and sent to me. So thanks for that, Neil. And we're going to go through this video and take a look at doing the drawing. And my goal is to get through the CAD and the CAM in around 15 to 20 minutes. So let's hop into it. I'm going to start off by hitting save and naming this file T-slot nut. When I'm happy with the name, I'm going to go ahead and hit the save button. Now I could just start drawing the geometry. I'm going to make a component. So I'm going to right click and say new component, and the component I'm going to name this nut and hit save. And I want to make sure this doesn't move around, so I'm going to do an as-built joint between the nut and the origin. I don't even have any geometry drawn, but I know what I draw can't move anymore. I'm going to create a sketch on the front plane, and I'm going to grab the 2-point rectangle, but I really want the center point rectangle. But rather than going through the menu, I'll just come over here to the sketch palette and choose center point rectangle. Drag this out. For a height, I want this to be 0.5625, and for a width I want this to be 22 millimeters is what I need. Now I'm working in inch units right now, as everybody should. Sorry, kidding, that was a joke. I'm working in inch units, and rather than converting it, I'm just going to have Fusion do the heavy lifting for me. I'm going to type in 22 and then put mm after it, and Fusion, when I hit enter, will convert that number for me, and I don't need to know what the conversion factor is. I'll finish the sketch, and now I'm going to extrude that. I'm going to extrude it symmetrically, a total distance of 1 inch. My stock is, most of the stock pieces are about 1.03 inches, so I'm going to I should have enough to clean up all of these pieces. Now I need to put the little shoulder cuts on, so I'm going to create a sketch again on the front face of the part, and I'll use the 2-point rectangle this time, anchored to the upper left. And I don't know what the depth is, but I'm going to hit tab because I know what the width is. So I'm going to type in 0.125, and that's what I want the width of that to be. I'll hit D for dimension, and from the bottom edge to the bottom edge of the rectangle, I know that's 0.335. And I'll hit enter, and I'll finish my sketch. Now I can extrude that. I'll just pull it the direction I want to go. For the distance, I want it to go all the way through, so I'll choose all, and then I can hit OK. I want to mirror that to the other side, so from the create menu, I'm going to choose the mirror command, and it's set to mirror faces. I want features, which means I can either select it on the model, or I can grab it on the timeline. Either way will give you the same result. And on the mirror plane, I want to use that origin plane that I can see, which is a little hard to get to right now. However, if I just put my mouse over it and I left click and hold until the select other menu appears, now I can stop left clicking and click on my YZ plane, and I get the preview of the cut. I'll hit OK. The last thing I have to do for CAD work is to put a hole in the center of this part. So I'm going to start the hole command, and I want to put it on this top face, and usually people's inclination is to select exactly at the center. I want to select off the center. Now I can take that blue dot and drag it to the white dot, and when I have it there, I can set my distance as all. I want this to be a tapped hole, and then I'm going to select a nominal 1/2 inch hole, and the thread designation is going to be 1/13, and I'll hit OK. And now the CAD work is done. It might be a good idea to save here. Now I can switch over to the manufacturer environment. I'm going to rotate my model slightly. This is how I'm going to be looking at it in the vise. And so I'll say I want to create a new setup. I want to change the X direction. So I'm going to click on the base of the X, and the face I want to be perpendicular to. So my work coordinate system is now where I want it. And I'm just going to go to the setup tab. Let me drag this out so you can see the names. I'm going to go to the stock tab and choose a fixed size box. And the first thing I like to do is set my round nearest field to be 0. Now my stock and my part are exactly the same size. So I'm going to tell my stock it's a little bit longer than what it really is. So most of the pieces, like I said, are cut to about 1.03. I'm going to say that this is 1.0625. It never really hurts to say your stock is a little bit bigger, and it can hurt if you say your stock is a little bit smaller. On the Y, my stock is going to be 1 inch. And for the Z height, it's 0.75. If I look at my stock, it's split the stock equal top and bottom. I want to change the Z model position to offset from the top. And I'm just going to take about 10 thousandths off the top to clean the steel up. And that should do what I want. And then on the post process tab, I'm going to change my WCS offset from 0 to 1 and I'll hit OK. That'll give me a G54. So now I'm ready to start adding tool paths to my part. Now I should note, I've already pre-set up my tools with the right feeds and speeds for what I want for this material. So I won't be picking any feeds and speeds. I'll just be picking tools as I go. I'm going to choose the facing operation and I'm going to go select a tool out of my Sile X7 steel library. And I'm going to start with this 3/8 inch helical tool. And you can see I've got a couple presets for adaptive clearing and contouring. I'm going to just select the tool and then I'm going to use air on the geometry. I'm not going to select anything. On the heights, it's going to go from the stock top to the model top, which is good. On the passes, I'm going to do a pass extension of 0.2 inches and I'm going to do a stock offset of 0.1. Just make sure it cleans everything up. Now it defaulted my step over to what my adaptive clearing step over is. I can get away with a much larger step over here. So rather than using that 0.045, I'm going to right click and say reset to system default, which is slightly less than 3/8 of an inch. And I'm only going to climb mill this tool path. Linking tab, I'm going to choose extend before retract to get the tool all the way off the stock before it retracts and hit OK. And there I should just get a simple facing operation. I'll do a 2D adaptive clearing with the same tool. Again, air, and then for the preset, I'm going to hit the drop down and say adaptive clearing is what I want to use for the geometry. I'm going to click on the top edge right there. So you get kind of a blue preview. Now there's really not that much meat there. We'll see if Fusion even puts a tool path on the different ends. If it does, great. If it doesn't, that'll clean up in the 2D contour pass. Because I selected at the very top of the part, I selected at the wrong height. So for the top height, I'm going to say model top because I face it to that level. And for the bottom height, I'm going to say a selection and I'm going to choose that face right there. On the passes, my 0.045 step over is it's about 12% of the tool is what my step over is set to for the steel part. And if I were to turn on multiple depths, it will go 3/4 of an inch deep. I don't need multiple depths for this first step, so I'm not going to enable that. I want to leave about 10 thousandths of an inch of stock radially and axially. And then I'm going to go over to the linking tab. I'm going to make just a few changes here. I'm going to set my stay on level to 70%, and my lift height to be 0.01, and my no engage and feed rate, I'm going to set that at 1,000. My machine can't do a cutting feed rate of 1,000 inches per minute, but what it will do is go as fast as it can, and the control doesn't mind if I put a larger number than what it can do. It just changes it to as fast as it can go. So I'm happy with those numbers. If you guys want me to do a deeper dive into what these things are doing and what they're important for, please let me know in the comments below. I'll hit OK, and now I get my adaptive clearing for that very first step. I'm just going to right click and duplicate that, and I'll edit that. I'm going to throw away my geometry. I'm going to select the new geometry at the very bottom of the part. And then on my heights, I'm going to make a couple adjustments. I'm going to say I want to go from a selection, which is going to be that face, to I'm going to say selected contours, or I could say model bottom. And now I want to cut past the bottom of this part by negative 0.02 inches. I'm going to go 20 thousandths of an inch past. The passes should already be all set up for me based on the previous operation that I did. Same with the linking. So now I'll hit OK. And there I get a tool path that just goes and roughs the outside of the part. Now I can work on cleaning the part up. I'm going to start out with a 2D contour. Same tool. I'm going to click on this edge for the geometry. For my tangential extension distance, I'm going to do about half the distance of the tool. I'm going to type in 0.15 here. That's going to make the tool start in space and end in space instead of starting farther away. It'll start farther away from the geometry. On the heights, stock top to selected contours is fine since it's only doing one step down. And on the passes tab, I'm going to turn on repeat finishing pass. I want to change something in the linking, but before I do, I'll hit OK. And you can see that the tool's doing 90-degree lead in and lead out. I don't need that. I'm going to edit this. I'm going to go back to the linking tab and I'm going to change my lead in sweep angle to be 0. Now what it'll do is it'll go across, retract, come back, make another pass. I want to do the same thing on the other side. So I'm going to right click and say duplicate this operation. I'll edit this, go to my geometry, click on, throw away my previous selection and click on the new edge and hit OK. And now I've got that cleaned up. I can do that one more time. I can just right click and duplicate that. And I'm going to edit this and I'll go to the geometry, toss that, and choose that edge right there now. Still for the heights, my part is only 0.5625. I know I can comfortably go 2 times the diameter, so 0.75 deep, so I don't need multiple passes or anything like that, and this is just the cleanup pass around the outside. So I'm gonna go from the stock top to the selected contours, and I'll say minus 0.01. I will go past the bottom just a little bit to clean that up. And then in the passes tab, I'm going to turn on an option that I don't think people use a lot, which is, actually, let me just hit OK so we can see what we get here for toolpath. So there's what my toolpath looks like. I've got my 0 degree lead in, lead out on, and that's why it's starting in this corner. What I want to do is I want the tool to start off in space, come in, make a lap around, and then finish off in space. So I'm going to edit this toolpath, go to the passes tab, and under outer corner mode, instead of roll around the corner, I'm going to say keep sharp corners. I'm also going to enable repeat finishing pass, which is already turned on because I copied it from the previous operation. I'll hit OK, and now I get exactly the result that I want. Although it's not starting maybe as far off as I'd like, so I'm just going to go to the linking tab, and I'm going to change the linear lead-in distance to 0.1. Now when I hit OK, you'll see that there's a longer lead in on that toolpath. It really doesn't add any time, but it ensures I really start out in space. So now if I do a quick simulation, at this point, I'll turn the transparency off. If we hit play and let this run, you can see we get the facing operation. Then we get our adaptive clearing that roughs the majority of the material off on the first step, finishes the second step. Then we do a contour pass, another contour pass, and a contour pass all the way around the part with a finishing pass, and away we go. So that's where I'm at for this part right now. I just have the drilling and tapping to do. I'm gonna go grab a drill, again, out of my Style X7 library for steel. And what you'll notice is I've got a 1/4" spot drill. Also notice it doesn't have a number next to it. So we'll see what happens with that in a second. So I'm just gonna go down to low carbon steel drilling. This is a tool I copied from the Autodesk tool library and just put my holder on it. And then now I'm gonna go to the geometry and click on this hole face. And for my heights, I'm gonna say hole top for the top height, but for the bottom height, I'm also going to say hole top. And then in the bottom height offset, I'm gonna say negative 0.0. Maybe I'll just peck down 30,000ths of an inch just to get a little point there. On the cycle, drilling wrap it out will be fine. And there's my preview of the spot drill that I'm going to do. I'll come back and do a drilling operation now. I'm gonna select my tool again out of the Style X7 steel library, grab my 27/64 drill, and again, low carbon drilling. For the hole, I'm gonna select on that face, and for the heights, hole top to hole bottom is fine. I wanna drill through the bottom, and I'm gonna put a 0.1 or 100,000ths breakthrough depth on there. On the cycle, I'm gonna choose chip breaking, partial retract, and I'm just gonna make one change here. For the accumulated pecking depth, I'm gonna set that to be 0.25. So every time the tool goes down a 1/4 inch, it's gonna pull out and clear the chips before it starts its next peck back into the material. If we look, the tool is clearly going through the bottom, so I'll hit OK. And I've got my drilling operation. The last thing I want to do on this side is I want to do a thread milling operation on my thread, which is 1/2-13. From the 2D menu, I'm going to select the thread, and I'm going to again go grab the tool out of my library, X7 steel, and I'm going to grab this Harvey thread mill. I've already set the presets for steel. I didn't make multiple presets, so I'll select that, and now I'm going to grab the geometry, click on that. For the heights, it's going to go from the hole top to the hole bottom, which is fine. Typically on a through hole like this, I'd make the tool go farther past the bottom, but I actually want this so that when I put a fastener in from the top, that when I tighten it down, I can't tighten it so much that I end up hitting the table. So if I don't complete all the threads, I can't turn the fastener into the table. So I'm going to leave it hole top to hole bottom. And the reason I say that is the tool, maybe we can look at that in a second, it doesn't start exactly at the bottom of the hole when you see the geometry. On the passes, I have a couple questions to answer. The first is the thread pitch. So this is a 1/2-13 thread, which means that there are 13 threads per inch. And so in order to calculate the thread pitch, I can either do the math on it or I can let Fusion do it by typing in 1 divided by 13. And now it'll calculate that value. The next thing I have to do is the pitch diameter offset, which is the difference between the major ID and the minor ID. This is a 1/2 inch hole, so the major ID is 0.5, and the minor ID is 27/64 or 0.421875. And if I do the math on that, the pitch diameter offset comes out to be 0.078. So that's what I'll do for the first one, and I'll see how the fastener fits after I do it. I want to do that in multiple passes. I'm going to do 2 passes of 20,000ths of an inch each pass for the total depth. So you can see I'm about 80,000ths deep. So that would be 40 per side. Split that in 2. So about 2 steps of 20,000ths of an inch. On the linking tab, there's one thing I'm going to change, but I'm not going to change it until we run the simulation. I'll hit OK. Maybe I'll hit save here just in case. And now I'm going to click on my setup, simulate, and really all I want to see is that threading operation. What I was talking about earlier is the control point of this tool is at the very bottom, but the threads don't start cutting until a little higher up. That's why saying whole bottom isn't going to give me full threads past the bottom of this part. So there's my thread mill. And if I hit play, what I should see if I slow that down, let me go back a little bit, go back to the previous operation. You see the tool turns red. The end of the tool is colliding as it goes into the material. So we're going to work on fixing that. There you can see the collision right there with the material being removed. The other thing that throws people off a lot when they thread mill is when you thread mill an internal hole, fusion starts at the bottom and goes to the top. So a lot of people expect it to go from the top to the bottom, and it gives them a little heartache. So let's see if we can fix that. I'm going to edit the thread operation, and I'm going to go to the linking tab, and I'm going to check this box called lead to center. Now I'll hit OK. If I simulate this entire thing over again and I click on my thread operation, now what we'll see if I slow this down a little bit is the tool goes directly down the center line of the hole, and then it starts to step over when it gets to the bottom, and no longer do I have that little crash. Another simulation trick you can do is if you shut off your models, you sort of see your threads better. Now you can see that I'm seeing a lot of red in my thread, and that's okay because what Fusion does is it models the hole at the minor diameter. So when this cutter is cutting into the thread depth, that's exactly what's going to happen. However, Fusion thinks a gouge has happened. In this case, it's a gouge we want. I'll hit OK, turn my model back on, and that completes my topside setup. Now what I'm going to do is I'll just have to decide, do I want to flip the part front to back or left to right? I'll flip my part left to right, and I'm going to create a new setup. I'll click on my Z arrowhead to flip it the direction I want, and click on the base of the Z in the face I want to go to. And I'm going to choose a stock box point, but this time I'm going to choose a stock box point at the bottom of the model down here. Actually, I'm going to change my mind. On this, I think what I'll do is a model box point. And I'll choose that point right there. So you can see that theoretically I won't be able to accurately touch off on this part, but what I'll do is just, I'll put some kind of a vise stop or a set of vise jaws across, parallels across, that I'll push that up to so I can touch off on that part. I'm gonna go to my stock and I'm gonna choose fixed size box, and I'm gonna use the exact same size as what I previously used. So I'm gonna set my round up to nearest to be 0. For my width, I'm gonna say 1.0625. For my depth, I'm gonna set this to be 1. And for my Z height, I'm gonna set it to be 0.75. But for the model position, I'll say offset from bottom, and I'm gonna set this to 0 so that the machine surface in the bottom is exactly on the parallels that it's resting on. Now that I have that set, I'll go ahead and hit OK. And I'll start out with a 3D adaptive clearing this time. I'm gonna go grab a tool out of my document, and that tool is gonna be my 3/8 inch end mill. And I want my adaptive clearing operation for that. On my geometry, I'm going to not select anything. On my heights, I'm gonna cut from the stock top, but instead of model bottom, I'm gonna say model top. So we'll grab that. Over on my passes tab, everything should be set up the way I want. I'm gonna set a negative 0.05 for the radial stock to leave. I want it to cut outside the bounds of the stock for the XY. But for the axial, I'm gonna set this to be a positive 0.01 so I have something to come face off after this. On the linking tab, kind of the same thing. I'll set this to be about 70% stay down, 0.01 lift height, and a no engagement feed rate of 1,000. And I'll hit OK. And now we should get a toolpath that just goes and takes that hat off. And then I'm gonna steal my facing operation from the top. So I'll copy this, right click on my setup and say paste. And then I'll just right click on that facing operation and say generate. And now I have the backside operation done. So I just took off that hat of material that was left over, faced the bottom of the part, and everything should be done with this part. So I don't know what I'm sitting at for time right now. Hopefully I was pretty close to that 20-minute mark. You can see it doesn't take that long to draw and cam a part inside of Fusion, especially when you have some things set up like your tools and your presets and things like that. So what we're gonna do in a feature video is take this part out to the Sile, and we're gonna machine this thing on the Sile X7 so you can see how that machine cuts steel. Hope you guys like this video. If you have any questions, please leave them below. And as always, thanks for watching.